Okay, for this video, we'll be going through general properties of waves tutorial. Okay, but mainly we'll be doing the transverse waves because the longitudinal waves, which is the sound waves, we have not gone through in class yet. Okay, so question 1. State the main difference between transverse waves and longitudinal wave. So the transverse, when you see the word transverse, first thing that you must think of is perpendicular. Okay, for longitudinal, it will be parallel. So what do we mean by that? Let's look at the answer. Now, transverse waves travels and transfers energy in direction perpendicular to the direction of the vibration of wave particles. That means there are two directions. The first one is the wave direction. So example, this is my wave direction. Okay. And then I will also have my particle direction. That means the direction of vibration of the particles. Okay, and you notice that this is perpendicular if you are talking about transverse wave. Okay, then for longitudinal, it is parallel. That means the direction that the energy is being transferred is parallel to the direction of the vibration of the wave particles. So you need to think about the key terms: perpendicular for transverse and parallel for longitudinal. Next part, state an example of each type of wave. So for longitudinal, it is sound wave. That's the only one in our syllabus. For transverse, we have a few. We have light waves, water waves, and rope waves. Okay, so sometimes I think in class I show you using a slinky. So the slinky, if we were to vibrate it up and down, the wave will go this way. So it is a transverse wave. But for this slinky, is very interesting. If I were to vibrate it this way, the wave will go this way, but the direction of vibration will be parallel to it. So the slinky can actually exhibit two kinds of wave, either transverse or parallel. But when they ask you to list for examples, please state down these examples. Okay. Now state the relationship between frequency and period. Frequency is F, period is capital letter T. So whenever they're asking for a relationship, it's usually in terms of a formula. So T equals 1 over F, or F equals to 1 over T. You might also want to memorize what is the definition for period and what is the definition for frequency. Okay. Next, they are asking for the relationship between wavelength. Wavelength is actually lambda, frequency F, and speed. This is the wave speed. So we have this formula, V equals to F times lambda. Okay, displacement and amplitude, the relationship over here is that the larger the as displacement increases, amplitude increases. Actually, amplitude of a wave is maximum displacement. Okay, it is the maximum displacement. All right. Okay, that's question 2. Okay, now we come to question 3. A progressive wave is represented by the following graph. So the graph axis is dt graph, and we also have a d position graph. So this position is effectively a distance graph. Okay, so it is our dd graph and our dt graph. So what can we get from dt graph? Dt graph, we can get period, we can then get frequency. Okay, we can also get amplitude. Okay, amplitude, which is the maximum displacement. So this is a dd graph. So dd graph, what can we get? We can get wavelength. Okay, we can also get amplitude. So which of the following gives the speed of the wave? Speed is formula V equals to F lambda, right? Okay, so we should try to get our frequency from our dt graph. Wavelength, we try to get it from dd. Okay, so wavelength is actually the distance that the wave travels in order to complete one wave. So it is going to be y. Okay, for frequency, we need to get it from our DT graph. We need to get from the the period. So period is the time taken to complete one wave. So I did this in class, right? So X is the time taken to complete one wave, but our period is X. And since frequency is 1 over period, so it is 1 over X. Okay, so we substitute them together. V equals to F lambda. Our F is 1 over X. Our lambda is Y. So answer will be Y over X. So answer is C. Okay, so you need to know exactly what you can get from our DD and DT graph. Okay, so question 4, a wave travels from P to Q separated by the distance of 0.9. So maybe this is P, this is Q. In between, it is a distance of 0.90 meter. Now it shows the displacement, how it varies with time. So this is displacement of a wave particle. Okay, so it's like a video, okay, that shows where, what is the displacement of the particle at which point in time. Yes. Okay, so this is our DT graph. So I say again, we can get period. Once you get period, we can get our frequency. Okay, we can also get amplitude. Amplitude is 2 mm. So let's see. We also have a DD graph here. DD graph, we can actually get wavelength. We can also get amplitude. Okay, so using data from figure 4.1 and 4.2, deduce the amplitude of the wave. So amplitude is the maximum displacement. So it's actually 2 mm, right? So next, they're asking us for the wavelength. So for wavelength, we need to look at DD graph, which is our displacement distance graph. So it is the distance traveled by a complete wave. So if I start from here, this is a complete wave. So the distance will be 0.4 meters. Okay, but what if somebody decides to start from here? Okay, so 0.6, this is a complete wave. So in between, it is still 0.4. Okay, so basically you need to know when a wave starts and when it ends to help you determine the wavelength and also to help you determine the period if it's DT graph. So they ask us for the period. So period, we need to look at DT graph. So if I were to start from here, okay, this is a complete wave. Okay, so but there's no marking here. Okay, so how about I do one more? So total, now there are actually 2 waves completed in 2.5 seconds. That means one wave is completed in 1.25 seconds. That means this is going to be the period. Okay, 1.25 seconds. Now frequency is F. F is equals to 1 over period equals to 1 over 1.25. So the answer will be 0.800 hertz. Okay, next, the speed of the wave. We have to use V equals to F lambda. Okay, so the frequency is 0.800. Lambda is 0.4. So it will be 0.320 meter per second. Okay. Okay, question 5. A long spring is shaken from side to side continuously to produce a transverse wave. So in this case, we will be doing a transverse wave. Distance between successive peaks. So peaks is also what we are known crest. Okay, the maximum displacement. So distance between successive peaks is 0.6 meters. So it means if I have a wave, okay, so this is one peak, this is another peak. So the distance between successive peak is actually your wavelength. And in this case, it is 0.60 meters. Okay. They also provide with us the frequency. Okay, so our lambda, our wavelength is actually 0.60 meters. We have frequency 2.5 hertz, And because wave speed is v equals f lambda, so 2.5 multiplied by 0.60, I can actually get wave speed of 1.5 meter per second. Okay, but they want us to calculate the time for the wave to travel 3 meters. So if the wave speed is 1.5 meter per second, therefore using time equals to distance over speed, okay, it will be 3 over 1.5 equals to 2 seconds. Okay, so basically you need to annotate, you need to understand what all these numbers that were given, what do they represent. Now they want us to draw a DD graph for this wave and label this as A. So I will start with this. Okay, so somewhere I need to indicate that the wavelength is 0.6. So this is a good point, 0.6. Okay, so this is our distance, and this is our displacement. Okay. Okay, and because they didn't tell us what is the amplitude, so we'll just leave it as that. Try to make sure that it is the same height throughout. Okay, so means I can have here as 0.30, here will be 0, here will be 0.90, and I need to label this as wave A. Okay, now on the same axis in part B, sketch another graph that represents the wave of the spring if it is shaken at a frequency of 5 Hz. Okay, so if it's shaken at a frequency of 5 Hz, just now the previous one, the frequency was 2.5 Hz. That means every time, okay, a complete wave is done for A, I should have 2 waves completed for B. Because what is frequency? Number of waves completed per second. Okay, so for B, the frequency is actually 5 Hz. Double that the frequency of A, right? So maybe I write over here, FA equals to 2.5 Hz, FB is equals to 5 Hz. That means every time I see one wave done for A, I would actually see 2 waves done for B. Okay, so I need to complete one wave here. That means I need to have double the number of waves. Okay. Okay, question 6. The diagram below shows an instantaneous position of a string as a transverse wave traveling from left to right. Okay. So by drawing another waveform next to the given waveform for a short time later, which is basically asking you to draw next wave, determine which one of the following correctly shows the direction of the velocity of the points 1, 2, and 3 on the string. Okay, so basically I need to draw the next wave. Okay. Yeah. Okay, so after you have drawn the next wave, you need to draw a vertical line of that particle cutting down. Okay, cutting either up or down. Okay, where it intersects with the next wave. So for point number 1, it actually moves down. Okay, so I have C. For point number 2, it actually intersects up here. Right, so it went up. For 3, it went down. So answer is C. Okay, so basically it's the drawing of the next wave and using a vertical line to see where does the particle actually cut the next wave. Okay, question 7, we have a DD graph. So DD graph, we can get wavelength. So it's good to always like determine what is the graph that you're dealing with and what are the things that you can get from it. Okay, so it shows a transverse wave, then draw the displacement time graph for particle A, and for B from t equals to 0 to t equals to 2t. Okay, 2t means 2 period. Okay. So how do we approach this? Okay, so what will A do? A, if we were to look at A, currently at t equals to 0, okay, it is at the bottom. Yes, t is at the lowest point. Okay, we are translating just particle A. Okay, and then what is the subsequent action of A? A will be going up, right? But once it reaches here, what will it do? It will continue to move up. Yes, it reaches the highest point, then it comes down, then it goes back to original, and that will form one cycle of what A will be doing. Okay, so we are dealing with particle A first. Okay, so I repeat, basically A is now at the lowest point. Okay, so it is at the trough. Okay, then after that, one step later, it will end up at the center position. One more step later, it will go up to the highest point. One step later, you'll go down to the rest position. One more step later, you'll go back to its original, forming a complete cycle. So this is our 4 steps. That means particle A is going to be here, 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 right? But as time goes by, it will not be at the same position, right? So let's say this is one period. Okay, let's say this is one period, right? So we split up each period into 4 equal quarter. So where will it be after one step? Over here, right? After one step, it will be this way. One more step later, you'll be at the highest point. Yes. Then one more step later, it will be, so maybe I need one more quarter, yeah. One more step later, you'll be at the rest position, and then one more step, it will be at the original position as it was. This forms a complete cycle. Okay, but they want us to draw for 2t. Okay, so you go up this way, and this is 2t. Okay, so from here to here is actually t quarter. Here to here is t over 2. Here will be 3t. Yes. Okay, so now let us look at B. Okay, at B it is here. The wave is actually traveling to the right. So now, compared to A, it's slightly more difficult because I don't know whether B will be going up or down, right? For A, it's very obvious. I erase. For A, it's very obvious. If it's at the lowest position, okay, the next step that you'll do is go up. Yes. If it's at this highest position, the next action that you'll go is down. But for these guys who are in the center, like B, we wouldn't know whether they are going to go up or down, right? So that's where we will need to draw our next wave. Okay, why do I draw the dotted line to the right? Because the question says the wave is traveling to the right. So I draw my dotted next wave to the right of the original wave. And the next thing that I need to do is draw a vertical line through that particle to see where it cuts the next wave. And it went down, right? Yes, it intersects it downwards. That means B is going to start off with downward motion when t equals to 0 when the t starts. So initially B is going to be here. Okay, one step later is going to go down to the lowest point. Yes, then it will go up to the highest and then back to original, and this will be a complete wave. Correct? You see that it forms a complete wave, yeah? But they want 2t, so they need 2. Okay, so this is 2t. So over here, this quarter will be 1/4 of a period. This is another quarter, so now it's t over 2. Now here will be 3t over 4, and here will be a complete period. Okay, so basically you need to remember your 4 steps. You need to be able to draw the next wave and see where it's traveling. Okay. Okay, question 8. The ocean waves are observed to travel along the water surface during a stormy day. Okay, a coast guard at the weather station observes that there is a height of 4.6 meter between the highest point and the lowest point of the wave. So if I were to draw a sketch, okay, the highest point to the lowest point is actually 4.6 meters. Okay, so this is the vertical height. A horizontal distance of 8.6 meters between adjacent crests. So this is 8.6 meters. So this is actually my wavelength. Okay. Now the waves splash into the ocean once every 6.2 seconds. So every 6.2 seconds, there's one wave. So with that, I can say that this is the period. So calculate the frequency. Frequency is actually 1 over period. So it is 1 over 6.2. I will get 0.161 hertz. Okay, so you must be able to distinguish what all this information means. Next, they want us to calculate the speed, which is v. Now we can use v equals to f lambda, or we can use v equals to lambda over t. Why? Because frequency is related to period by this formula. Okay, so I can use my wavelength, which is actually 8.6 over period of 6.2. So I will get 1.39 meter per second. Okay, so basically it's just to interpret what the information given in the question. Okay, we can still do question 9. A person at a fishing pier is observing the behavior of the water waves in the sea. Water waves, it means it's transverse, so we can still do. He observes that the fourth crest passes by at 7.0 seconds after the first crest and estimates that the distance between 2 successive crests is 4.0 meters. So for this, the wavelength is 4.0 meters. But what is more important is that the fourth crest passes by at 7 seconds after the first crest. That means this is my first crest. Let me draw second, third, and fourth. So this is my first crest. Okay, my second crest, third, and fourth. So actually we need to take note that because at the when the first crest passes, example, if the time is 0, let's say on a stopwatch, okay, 7 seconds later, then I see the fourth crest passing by. That means in between there are actually 1 period, 2 periods, and 3 periods. Okay, so this is a trick here. 3 periods is actually 7 seconds. Okay, because if you read the question, he says that the fourth crest passes by at 7 seconds. That means 7 seconds later, after the first crest passes, then the fourth crest comes in. That means I start the stopwatch here at t equals to 0 seconds, first crest, second crest pass by, third crest pass by, fourth crest pass by, and the time on my stopwatch shows 7 seconds. Okay, so is it that there are 4 periods? No, because this is 1 period between the first and second, between second and third, between third and fourth. So basically there are 3 periods. Alright, so this is the difficult part about this question. Okay, but after that, if you can get this, so my period is 7 over 3. Okay, and this is easy. My wavelength is 4 meters, so we use V equals to F lambda, or V equals to lambda over T. We can get 4 over 7 over 3. Okay, so the answer will be about 1.71 meter per second. Okay. Okay, question 10, we can still do. Two boats anchor at 4 meters apart. Okay, bob up and down periodically due to the waves on the surface of the sea. However, when one boat is at the highest point, so example, this is the boat. Okay, at the highest point, the other one is at the lowest point. So this is boat A, this is boat B. Okay. And vice versa. They return back to their highest position every 3 seconds. Okay. So they are anchored at 4 meters apart. But now, because one is at the crest, the other one is at the trough, so basically their distance, horizontal distance them is 4 meters. Okay. But this is only half a wavelength, right? Because wavelength is from successive crest to crest. So wavelength will then be 8 meters. Okay, so again, this is one of the trick in the question. Okay, now they say they return back to their highest position every 3 seconds. That means A, it goes down, down, up, up. Still remember the 4 steps? So it returns back after 3 seconds. That means the period is 3 seconds. So they want us to calculate the speed, V equals to F lambda. And because we are given a period, so we can just use V equals to lambda over T. So it will be 8 over 3. Okay, let me check the answer. So it will be 2.67 meter per second. Okay, I think this is sufficient for your holiday homework. Of course, I upload this. Some of you will just purely copy the answer. Well, at least it's better than nothing, right? At least you still bother to watch the video and then write down, and hopefully some learning takes place. Okay, but for those who have done your holiday homework, please check the answers as well. And then after that, if you have any questions, can ask me. All right. You are supposed to hand in this on the first week, first lesson. Thank you.